In this video, we're going to look at integration formulas. These will give us ways to find integrals without just, guessing. Okay, so the first one is the integral of a constant. So if k is any constant, we want to find the integral of k, let's say dx. Okay, we're asking what's the function whose derivative is k? Whose derivative is that constant? Well, the function whose derivative is k times x, because the derivative of a constant or coefficient times x is its coefficient, plus any constant, or the constant of integration, because the derivative of every constant is 0. So for example, the integral of 1.5x dx is the integral of 1.5 dx is 1.5 times x plus c. Next is the integral of a power function. So if r is any real number other than -1, then the integral of x to the power of r. Okay, for this we need a way to essentially undo what's called the power rule in derivatives. Okay, and the power rule says you bring the power down out front and you decrease the power by 1. We want to go backwards from that. So because normally you bring the power down out front, we have to account for that with a 1 over r plus 1. And then we have to add 1 to the exponent. Okay, because when you differentiate, you decrease 1 from the exponent. So we're doing the opposite. And then plus the integral, constant of integration c. Okay, let's look at two examples here. So first, the integral of x to the 4th. So r corresponds to that 4. Okay, so according to this rule here, we're going to add 1 to get 5, and we're going to put 1/5 out front, and then we'll have x to the power of r plus 1, or 5, plus c. Now you can check any derivative rule by differentiating your answers. Let's go ahead and check this one. There we go. By taking the derivative of our answer and seeing if we get back x to the 4th. So I want to take the derivative of 1/5 x cubed, x to the 5th, plus c. So the 1/5 hangs out front, and the derivative of x to the 5th is 5x to the 4th. And the derivative of a constant is 0. So the 1/5 and the 5 do cancel, and we do get x to the 4th, 0, x to the 4th, okay, which is the integrand. Okay, so that looks correct. Then next, the integral of the square root of x. Well, we don't have a rule yet for radicals, and there is no rule specifically for radicals, because every radical can be written as an exponent. So the technique here is to rewrite it before integrating as x to the power of 1/2 dx. And now our exponent r is the number 1/2. So we're going to add 1 to that to get 1/2 plus 1, which is 1 over 3/2. 1/2 plus 1 is 3/2, times x to the power of 3/2 plus c. And we need to simplify. 1 divided by 3/2 means 1 times the reciprocal of 3/2, or 1 times 2/3. So the simplified solution, or antiderivative, is 2/3 times x to the 3/2 plus c. You could convert that back to a radical, but most people just leave them as exponents. Okay, the next rule is the integral of a constant times a function. If you have a constant k out in the front of a function, okay, then the integral of k times some function f of x dx is equal to k times the integral of the function that you're trying to anti-differentiate. Okay, what I'm doing is bringing that k out front. And that's because when you differentiate, you can bring a constant out. So when you go backwards, it's the same thing. You can still bring a constant out. Okay, so for this example, we have the integral of 6x squared. So what we can do is bring the 6 out first by this constant rule to get 6 times the integral of x squared. and the 6 just hangs out front. Now the integral of x squared, for that we're going to use this power rule up here. The 2 corresponds to that r. So by this rule, it's 1 over 2 plus 1, or 3. So 6 times 1/3 times x to the power of 3. Now I could put my plus c here inside parentheses, but it doesn't really matter because the derivative of any constant is 0. So whether I distribute and have a 6c or just plain c, it doesn't matter because c just represents some arbitrary constant anyways. So it's usually just tacked on to the very end of the integral. Okay, simplifying 6 times 1/3 gives us 2x cubed plus c. Okay, the next one, find the integral of 3 over x squared. Okay, we don't have a rule or a way to antidifferentiate fractions, so instead we need to rewrite this so that we can find the antiderivative using the rules that we have. Well, luckily we can rewrite x squared as x to the negative 2 dx. Okay, and by this constant rule we can pull the 3 out front to give us 3 times the antiderivative of x to the minus 2. And now we can apply the power rule up here. The exponent we have is negative 2. So when we add 1 to that, we're going to get negative 2 plus 1. Negative 2 plus 1 is negative 1. So we have 1 over negative 1 times x to the negative 1 plus c. Or if we simplify that, it comes to negative 3 x to the negative 1 plus c. Or you could go back and write it as negative 3 over x plus c. All right, next we have the integral of a sum or a difference. So if f and g are any two functions, then the integral of f of x plus or minus g of x, if you're adding or subtracting it works, can be split into two integrals. The integral of f of x dx plus the integral of g of x dx. I'm going to move that down a little bit here. Here we go. Okay. All right, so say we want to find the integral of 3x squared minus 2x. Okay, so by this rule we can split this into a difference of two integrals. The integral of 3x squared, we need to put the dx there to indicate that's the end of that integral. Oops, I left off a minus here, plus or minus. So in this case it's minus the integral of 2x dx. Now most of the time people do not rewrite the integral when they pull out the constant, okay, as I did right here. They don't actually pull out the constant and put 6 times the integral. Most of the time people jump straight from this step, straight from the integral to here. They just kind of pull the constant out in their head and then anti-differentiate x squared to get a third x cubed. So that's what we're going to do down here. So we'll have 3 times the integral of x squared, add 1 to that exponent to get 3, so it's 1 over 3 times x to the third. Now we could put a plus c here, but again, since c is an arbitrary constant, we'll just wait till the very end. Okay, then for this integral, it's the integral of minus 2x. So the minus 2 comes out front, and then the exponent on that x is a 1. We just don't write it, but it's a 1. So we add 1 to that to get 2. So by the derivative rule, it's 1 over 2 times x squared. And then we'll put our plus c at the end there. Simplifying, right? 3 times a third, those cancel, so we get x cubed. And 2 times a half cancels, so x cubed minus x squared plus c. Now if we differentiate this, we'll get the integrand here. Next is the integral of an exponential function, and that's of the e to the x. Okay, you might remember that the derivative of e to the x is itself e to the x. So this one's the easiest rule. So the antiderivative of e to the x is also e to the x plus an arbitrary constant. Okay, or for the integral of a reciprocal function. This one I actually would like to derive. Let's say that we want to, not derive, but explain more fully here. So let's say that we want to find the integral of 1 over x dx. Okay, let's put this, we'll put it up at the top and we'll put the explanation below. So we want to integrate 1 over x dx, okay? So you might remember that the derivative of the natural log of x is 1 over x. Okay, so this is the antiderivative, but I'm not quite done with it yet. We need a little bit more to it here. But partly because, well, in part because, the domain of the natural log function is simply x greater than 0. It's only positive numbers. But it just so happens to work if we put absolute value bars there as well, which allows us then, well, it's more general. It allows negative values of x to be used, okay, if x is a variable. You still can't take the log of 0, but that's okay. Can't plug 0 into that denominator anyway, so. Okay, so why is this? Well, let's check here. So natural log, or absolute value of x, let's write that first as a piecewise function. So the absolute value of x is equal to itself if x is greater than or equal to 0, or it's equal to negative x if x is less than 0. Okay, so if we are differentiating the derivative of the natural log of x, let's just check here. Oops. The derivative of, what we're going to do is we're going to take the derivative of the natural log of x, and we'll take the derivative of the natural log of negative x. Okay, we're going to break it up into its piecewise function to show that both derivatives do equal 1 over x. So let's first differentiate the natural log of x. And this is if x is greater than 0. Okay, then the natural log of the absolute value of x would be equal to the natural log of x. So the derivative of our solution, I'm leaving off the plus c, but the derivative of the natural log of the absolute value of x is equivalent to the derivative of the natural log of x, because when x is greater than 0, the absolute value of x equals x, and the derivative of the natural log of x is 1 over x. Okay, so it works right there. Now, if x is less than 0, then the derivative of our answer, natural log of the absolute value of x, can be written as the derivative of the natural log of negative x. Okay, that's because when x is less than 0, absolute value of x is defined by negative x. Okay, so for the derivative of negative x, we use the chain rule, where the negative x is the inside function. So we have 1 over negative x times the derivative of negative x, which is negative 1. So that also simplifies to 1 over x. Okay, so because the derivative of natural log of absolute value of x works, you do get 1 over x, whether x is less than 0 or greater than 0. To be really general here, we put absolute value bars, okay, which allows, again, more values of x to be used. Okay, so let's look at this example here. So we have the integral of 4 over x plus 2 e to the x. Okay, so using our antiderivative rules, we can split it into two integrals. At the same time, I'm going to go ahead and pull the constants out, and I will show this step this time. I'm going to write it as 4 times the integral of 1 over x dx plus 2 times the integral of e to the x dx. So we get 4 times the natural log of the absolute value of x plus 2 times e to the x plus our constant c.